Remember, lesson 1 was about electricity. We have discussed currents, we have discussed potential difference, we have discussed resistance, and the conversion of ammeter and voltmeter to galvanometer. So let's quickly look at the past question. And this is from SSCE 2022. It said 3 cells, each of EMF 1.0, and internal resistance of 2 ohms are connected in parallel across a resistor, external resistor. Determine the current in the resistor. Now, I told you in the course of the teaching slide that whenever internal resistance is mentioned, it means the formula to be used will no longer be V equals to IR, but the extension of that formula. So what will be the answer to this question? All right, so the answer to this question is 0.30, but then how do we get here? So let me quickly put you through how we got that answer. All right, so E is 1.0 volts, and then external resistor or resistance is 3 ohms. Then 1 over R is equal to 1 over R times 3. So R is 1 over 3 ohms. Now, what is really happening here? Remember, we were told that 3 resistors were involved. So if, 3 cells, were involved. Each of the cells has 1 volt. So why are we using 1 volt and not 3? That is because the cells were connected in parallel. So please take note of that. If you have cells arranged in series, the total potential difference will be the addition of each cell, E1 plus E2 plus E3. But if you have the cells in parallel arrangement, then the total cell, no matter how much cells were given in that circuit, will just be the cell, the value cell of 1 cell. So in this question, we have 3 cells. Because they were connected in parallel, I will only pick the value for 1, not the 3 cells. So that is why we have EMF here as 1 volt instead of what? 3 volt. Does that make sense now? Okay, so external resistance is 3 ohms, 1 over R. Now, why did I do this? Because the resistors value were the same. So if I can find the value for 1, then I've equally found the value for the 3. Is that okay? All right, so let's continue and let's see how this was finally solved. This is the resistance, internal resistance is 0.3. So we have E equals to, this is the formula, the extension of Ohm's law. Now, by the time you make I the subject of the formula and then substitute the value, as you can see, this is 1, which represents E here. Then you have R, which is the external resistance, 3. Then you have internal resistance 0.33. So by the time you put all of these together, then your final answer should be what? 0.3 amperes. So that is why option C was the correct answer. I believe that was clear enough. Let's go to another question. All right, this is taken from SSCE 2022. So we have 3 galvanometer with a full scale deflection. I don't think this 3 is part of it. A galvanometer with a full-scale deflection of 20 milliampere is converted to read 8 volts by connecting a 395 ohm resistor in series with it. Determine the internal resistance of the galvanometer. Now, take note of this. It's converted to measure what? To measure voltage. So this is the conversion of voltmeter to galvanometer. So what will be the equation for that? All right, these are the options. And then from these options, we have, 2.5 as the answer. 2.5 is the answer to this question. So let's find out how we arrive at 2.5, ohms being the answer for that. Okay, let's quickly look at the solution. Rm. Why do we label it M? Remember, I told you the resistor used for converting ammeter to galvanometer is called shunt. But if it is conversion of voltmeter to galvanometer, you call it multiplier. So that is why we have this Rm over here. So Rm is 395 IG, current in galvanometer, is 20 milliampere. And then VT, the total voltage to be measured, is 8 volts. So VT equals to this. This is the expression. Now, what is our aim here? Our aim is to find the resistance of the galvanometer. So this is the expression VT minus this. I actually brought this from this formula. Remember, I explained all of this in this slide. Don't be confused with all the notations. I have to put those notations to make it a bit clearer. So VT minus IGRM is equal to IGRM. Now, from this equation, this is the unknown. Make the unknown the subject of the formula. So if you make RG the subject of the formula, what would that be? That would be VT minus IG times RM, which you have here. Can you see it now? Then divided by what? IG. Because our emphasis is on getting RG. And I always encourage physics students, whenever you are solving problems in physics, always ensure that you work on the formula to the last point before you substitute the value. By so doing, you'll be able to reduce all, multiple variables in the equation. So that's what I'm doing here. I have to reduce everything down to the one that is the subject of the formula. So RG is the required. Make it the subject of the formula. Once you get to this point, the next thing to do, substitute these values that you were given in that same question into the formula, and then play with the numbers using your calculator. You are good to go. So let's see how that will be done here. So under VT, we have 8. So replace this with 8. G, where is IG? IG is 20 milliampere. Milli here means 10 raised to power minus 3. Is a value less than 1. Then under RM for multiplier, we have 395. Put it there. And then under IG again, put 20 milliampere. Now, when you do all of that, this is it. The arrangement of the substitution of those values. So replace those symbols with the numbers. And then at this point, what do? Just use your calculator and play with these numbers. And then your final answer will be up. All right, so the final answer is 5.0 ohm. So that was how we got 5.0 ohm in solving that question. I believe that is clear enough. Let's look at another question. This again from 2022 SSCE. One major reason why electrical appliances in homes are normally earth is that, so why do we earth electrical appliances at home? Let me further explain this. Now, in a standard electrical installation at home, 3 cables are always involved. One is the red cable, which of course this carry what is called a light. This is the one that carries the current. And then the other one is the black cable. The black cable is neutral. Then there is another cable that is a mix of green and yellow. A green and yellow color, a mix. Now this is called the earth cable. Okay? Now in every electrical appliances with 3 pins, you always have this arrangement. If the plug is 3 pins, for 2 pins, you have just the red and the black. But for 3 pins, you have red, black, and then the earth wire. So for any standard electrical installation at home, you must have what is called earth wire. So why do we need to earth the home against this? The reason is to avoid electric shock and damages to the appliances. That is why we earth building. Now, a person touching the appliance is safe from electric shock. Appliances are maintained at a higher PD than the earth. Appliances are maintained at a lower PD. So what do you think is the answer? I've already given you the answer. It's to avoid risk of electric shock. So the answer should be A. A person touching the appliance is safe from electric shock. That is why a poorly installed electrical power sometimes affect the devices. That's why if you go to some homes, if you touch freezer, you touch television, you receive some amount of electric shock, especially when there is a leakage. Leakage means short circuit. When there is a short circuit somewhere, instead of that extra current to pass through the earth wire and go to the earth, it remains on that appliance. So whenever you touch it, you receive electric shock. So it's always good to earth the building to avoid risk of electric shock. And this one is very current, 2024, SSCE 2024. A galvanometer of full-scale deflection. Remember I told you, I've seen these questions time without numbers in WAEC, and that was why I took time to teach you how to convert ammeter and voltmeter to galvanometer. This should be the second time we are solving this question. Yeah. Now, a galvanometer of a full-scale deflection, 10 milliampere, has a resistance of 5 ohms. Calculate the shunt. Can you see that now? Calculate the shunt. So with this, seeing shunt here, it simply means this is an ammeter that is being converted to galvanometer. If it is multiplier, then I'll quickly know that is a voltmeter converted to what? Galvanometer. So how do we play around this? Let's see the option. These are the options, and then the answer to this is 0.025 ohms. 0.025 ohms. So let me quickly take us to the next page. Let's find out how did we arrive at this answer. First thing to do, list out all the parameters from the question. Okay, list out all the parameters. All of these were given. IG 10 milliampere, total current 2 amperes. We are looking for RS. That means shunts. Okay, RG was given, so we are looking for RS. What next? Go for the formula. Go for the formula. Now, voltage across shunt is equal to voltage across galvanometer. Why? Because this is a parallel circuit. In parallel circuit, the voltage is the same while the current is different. So I have to give that reason. This is the simple formula. With this formula, you can find your way out. Remember, we are looking for RS. This is the formula. So what will you do? Make RS the subject of the formula. So how do you do that? Look at it. Look at it. If this is equal to this, so in order to get RS, divide both sides of the equation by what? IT minus IG. That is what I've done here. I believe it's clear enough. You know, sometimes students complain that physics is difficult because of the mathematics, but I keep saying it. We only make use of part of mathematics, and that is algebra. Okay? And to be precise, change of subject of the formula. If you are good with your algebra and you are good with change of subject of the formula, you won't complain about physics, because that is what we use in solving problems. So make the unknown the subject of the formula. That is what I've done here. Now, when you are done with that, what next? Substitute the values that you got from the question. This thing is very simple. Substitute these values were given from the question. Substitute these values back into the formula. Let's see. In the place of ROG, what do you have? You have 5. Look at the 5 ohms here. In the place of IG, what do you have? 10 milliampere. This is a 10 milliampere. Remember, I told you milli means 10 raised to power minus 3. Then in the place of IT, total current, you have 2 ampere. This is the 2 ampere now. Minus IG. In the place of IG, again, 10 milliampere. This is the 10 milliampere. What next? Use your calculator and play with these numbers. And then you are going to get your final answer as 0.025 ohms. So this is how we got the answer to be A. I believe it's very clear and it's very simple. Let's continue. We still have more questions to play with. We still have more questions. This again is 2024. A cell of EMF 2 volt has an internal resistance of 0.5 ohms. A current of 0.4 ampere passes through an external resistor P. Determine the resistance of the P. Yes, we have discussed resistance in full detail, including resistivity. All right, okay, I think this was 2023. All right, so let's find out. These are the options. So how do you know the correct answer to pick? I'm going to show you, not to worry. So let's see what the answer here is. All right, the answer here is 5 ohms. So let's quickly go to the other side of the slide and find out how did we arrive at 5 ohms. The question is determine the resistance of P. Determine the resistance of P. Okay, let's find out. Let's find out. First step, you can see I'm using the same method in solving all these questions. The same method. And what is the method? List out the parameter from the question, figure out the formula to be used, and then make the unknown the subject of the formula, then substitute all the given value into the formula, and then lastly, play with the numbers using your calculator. So let's find out. So E is 2 volt, it was given. R is 0.5, it was given. I is 0.4, it was given. So RP is what we are looking for, question mark. So which formula will handle this? Remember I told you how to use this formula? Okay, this is an extension of Ohm's law. Let me remind you again in case you have forgotten. Remember Ohm's law says V is equal to IR. But in a situation where internal resistance is involved, you cannot use this formula. You will use this because this formula does not have provision for internal resistance. But this formula has provision. The only difference here is addition of small r and then V graduating to what? E. Does that make sense? Okay, so let's move forward. What are we looking for? We are looking for RP. So what do? Make RP the subject of the formula. How do you do that? Open this bracket. Open the bracket and then make RP. This is the RP here. Make RP the subject of the formula. And then what next? Substitute your values again into the final formula and then play with it. Let's go through it together. E is 2 volts. Look at the 2 here. Minus. I is what? 0.4. This is the 0.4 times. R is what? 0.5. This is the 0.5. Okay? 0.5. And then what else? I, the big I is 0.4. This is the 0.4. So what next? Play with this number using your calculator and then you will have the final answer as 4.49 ohms. I decided to put the whole raw data here so that you will actually understand that we calculated this. We don't just guess the answer. That's the beauty of physics. We calculate, we verify everything. So the raw answer is 4.49, but on the option there, the answer was 5 ohms. So how did we get to 5 ohms? Approximate this. So this is 4.49. If you approximate this, you get 5 ohms. Okay? Let's continue. Let's look at another question. The property of a body that determines the direction of heat. SSCE 2023. Heat flow when a body is in contact with another body is what? Okay, we have 4. We have heat capacity, we have mass, we have power, we have temperature. So the property of a body that determines the direction of heat flow is what? Is temperature. Heat is the internal energy of a system, but temperature is the measure of the degree of hotness or coldness of a body. So when you bring two bodies together, heat will always flow in the direction of lower temperature. What I'm trying to say is, if you have body A and body B, if body A has a higher energy level than body B in terms of thermal energy, heat will flow from A to B. All right, so we move to the next question. There's no calculation for this because it's just normal idea. Okay, I think this is another calculation question. I love calculations so much. Okay, so a lamp is rated 240 volts, 60 watts. Determine the resistance of the lamp when lit. Determine the resistance of the lamp when lit. So what should be the first step? List out all the parameters given. Okay, so what is the answer from this option? Let's find out. The answer is 960 ohms. 960 ohms. 960. Don't worry, I'll show you how we got 960 ohms. Let's go to the next slide. So first step, the parameters. List them out. So P was given, the bulb is rated 60 watts. The voltage across the bulb is 240. We are looking for resistance. So which formula relates or capture all of this? This is the formula. Remember, I gave you the distinction between electrical power and mechanical power. Electrical power is the product of current and voltage. What are we looking for? Resistance. This is a bit tricky. Why? Because in this formula, there is no resistance. So what will you do to make room for resistance? Go back to Ohm's law. How? Let me quickly show you that. Remember, Ohm's law says V is equal to IR, right? Now, in this expression, there is no R. How do I relate this so that R can come into it? It's very simple. Make R the subject of the formula. Okay, make I the subject of the formula. If you make I the subject of the formula, this will be, okay, let me write it here. So V is equal to IR. So if you make I the subject of the formula, I will be equals to V over R, right? So come back to this formula where you have P is equal to IV. In the place of I, replace it with what? V over R. So this formula can now be written as V over R times V. So what would that be? V times V is V squared over R. So that is how we graduated from P equals to IV to what? V squared over R. So whenever you come across question like this, don't panic. In physics, we always have a way. We can always improvise. We always have a way of getting things done. So with this, we are good to go. So V squared over R, we are looking for R, right? So what do? Make R the subject of the formula. I keep using the same pattern all the time. Make R the subject of the formula. And then what next? Substitute the values. So in the place of V, I have 240, but the formula says V squared, so that will be 240 squared. In the place of P, I have 60, so this is the 60. What next? Punch your calculator and then get your final answer as 960 ohms. The option was A, so that was how we got the answer. Let's continue. I think we still have more questions. Okay, this is solution 8, so 2 more questions to go. A current of 2 ampere passes through a wire of resistance 4 ohms for 3 minutes. Calculate the energy lost. Calculate energy lost. And I'm going to use the same pattern again. And what is that pattern? List out all the parameters. So these are the options. What is the correct answer? Follow me. The correct answer is 2,880 joule. 2,880 joule. I know you'll be wondering, how did you know? Let's find out. Let's find out. Don't panic. So step 1, list out all the parameters. Step 1, list out all the parameters. I was given, T was given. Now, what was given as T was 3 minutes. Remember, the SI unit for time is seconds. I told you. So whenever you are given time in minutes or hour, ensure to convert it to what? Seconds. How do you convert? Multiply by 60 because 60 seconds make 1 minute. Now, resistance was also given as 4 ohms. So what are we really looking for here? What are we looking for? Let's find out. Okay, but power is energy over time. If power is energy over time, it means energy will be equals to power times time. But then electrical power is what? I times V. Remember I told you electrical power is current times voltage. So if you put all of these together, you have IVT. So we are looking for E. We are looking for E. What is the voltage? So after doing all of this, we have IVT. But then there is a problem again. What is the problem? V was not given. So V was not given. What will you do? Look for a way to take out V and replace it. So I'm going to do the same thing again. Look at it now. P is equal to IV, but in the parameters, we don't have V. So what do? Go back to the original equation, V equals to IR. Make V the subject of the formula. So if V is IR, it means wherever I see V, I can do what? Put IR. So if that is the case, come back here. So I, in the place of V, times IRT. So what happened? I times I will give you I squared, then RT. You see, with this, we can always find our way in solving problem. So, what next? Substitute the values into the formula. Where you have I is 2. This is the 2. It was I squared, so we have it as 2 squared. Then where you have V, what was the value of V? Okay, where you have R was given as 4. Look at the 4 here. And then lastly, where you have T, what was T? T was 3 minutes. 3 minutes converted to second is 180 seconds. So with this, what next? Punch your calculator, and then the final answer will come out as 2,880 ohms. So this is why option C was the best answer. And then lastly, before we close on this section. A wire of cross-sectional area 2 pi times 10 raised to the power minus 8. Sorry, this is a typo error. This is 10 raised to the power minus 8 meters squared. And resistivity of 1.1, again, this is times 10 raised to the power minus 8 ohms meter. Has a resistance of 21 ohms. Calculate the length of the wire. Do you still remember this formula? Let me see if you do. Remember, I gave you a formula that resistance is equal to rho L over A. In other words, resistance inversely proportional to area, resistance directly proportional to length, and the constant of proportionality is called rho, the resistivity. And I told you resistivity is the amount of opposition offered by a material to the flow of current through them. So what are we calculating? We want to calculate L, the length of the wire. We want to calculate L. So what do? From that same formula, make L the subject of the formula. So if you make L the subject of the formula, what will happen? All right, let me show you the option first. These are the options. These are the options. So what is the answer? Okay, from this we have 120 as the answer to this question, but then let's find out. Don't panic. I'm going to show you how to do that, okay? So, step 1, the same method. I've been using the same method from question 1 to 10 because I want you to get used to this method. Yes, I want to get used to this pattern. It will really help. First step, list out all the parameters from the question. Second step, figure out the formula. Third step, make the unknown the subject of the formula. And then the last step, substitute the value into the final formula. So we have all of these given, right? Okay, so which formula will do this job? This is the formula. I wrote it there before. R equals to rho L over A. Rho is resistivity, L is length, A is area, R is resistance. So for this question, we are looking for L. So what will you do? Make L the subject of the formula. Make L. So that is it. If you make L the subject of the formula here, L will be equals to RA over rho. At this point, what do you do next? Substitute these values into the formula and then play with it. So let's go. In the place of R, where is R? I have 21. This is the 21 times. In the place of A, what do you have? 2 pi times 10 raised to the power 8. This is the 2 pi times 10 raised to the power 8. In the place of rho, what do you have? 1.1 times 10 raised to the power minus 8. This is 1.1 times 10 raised to the power minus 8. Is this still not simple enough? It's very simple. So at this point, what do? Grab your calculator, punch the numbers, and when you finish, press is equal to, and then this answer will come out. So this is how you solve physics question. No matter how you may see the question as being difficult. So guys, with this, we have come to the end of lesson 1. So I want you to look out for lesson 2. Thank you very much.